Hello and welcome to this tutorial. This set of tutorials will focus on how we represent binary fractions or real numbers into denary and we do the conversion. Now, dealing with binary numbers as integers is relatively straightforward, and we can see that through this example. We know that in binary we have 1, 2, 4, 8 and 16, and if I had another digit in there that would be 32, because it's to the power of 2, so it doubles every time. So I could look at that and say, well, okay, so that's 1, nothing there, nothing there, nothing there, 16 there, so that's 17 as an integer. But I need to deal with the fractional part. Now we can see that we have here what would be a decimal point, but we will call it a binary point. So that's 0.1. Now, in the denary system or the decimal system, fractions or the decimal parts are fairly straightforward. Tenths, hundredths, thousandths, tens of thousands, hundreds of thousands, and so on, decreasing by a power of 10 down to infinity. Well, the same sort of pattern works with binary. When you grow in binary, it's to the power of 2. In the decimal part of a binary number, it's to the minus. Now, we'll come to that in a bit. But first of all, we need to think about this. Okay, well, I can only deal with a 1 and a 0 in binary. So, we represent 0.1 as a half. Yeah. And then we represent 0.01 as a quarter, and the next one down as an eighth, and the next one down as 16. Now, if we know that 0.1 in binary equals a half, we can then put in there 0.5. There we go. And so we've got 17, ignore the leading 0 there, 17.5. Let's have a look at another example. Well, here we go. So we've got a typical binary string again. Let's deal with the integers. 1, 2, 4, 8, 16. And we'll put the next one in, although we haven't got anything to do. Okay, so I have all of my binary digits switched on, or they all have the value of 1. Now, a quick way to add up a string of binary digits, if they all equal 1, is to look at the next power up, and this would be the value of 32. It's always 1 less than whatever that would be. So I know that 32 minus 1 becomes 31. Let's have a look at the fractional part here. This is where our real numbers or our floating point numbers come in. So that's point, so that's point half or 0.5, that's a quarter, and that's an eighth. Okay, now we need to think about, so how do we represent that? Well, we know that a half is 0.5, a quarter is 0.25, and an eighth is 0.125. And if I add all of those up, and so that's 0.875. And so my final number will be 31.875. So the string of binary digits 1, 1, 1, 1, 1, 0.111 equals 31.875 in denary or decimal. Thank you very much for watching and listening.